Go ahead and get started. Thank you everyone for joining us. Before we begin, I'd like to go over some of the basic technical notes for the webinar. As you've already experienced, we're having a chat window off to the left. Please type your questions and comments in the chat window and we will try to answer them as quickly as possible. Please make sure that your speaker icon is green. If you can all hear me, which I believe you can, then you must already have your speakers turned on. That's good. There's also volume levels on the speaker icon. So if your volume is low, you might be able to turn the volume up. And if at any time you lose a connection or have any trouble, you can email us at climatecampaign@globe.gov. Otherwise, if you're still connected to Adobe Connect, please just send us a message in the chat window and we will address your concern. So this morning, the Student Climate Research Campaign webinar is on learning how to study climate using Globe phenology protocols. My name is Sarah Tessendorf, and I work in the Globe program office as part of the science and education team. I also want to acknowledge that there were contributions to this presentation from Elena Sparrow, Rico Gazal, and Martha Coughlin. So before we begin, I want to give you a quick overview of what we're going to be discussing today. Since the theme of the webinar is on phenology, I will first define what phenology is for those of you that may be unfamiliar. In particular, I will put it in context of climate and also discuss how phenology works with Globe. Then we'll actually look at some data. We'll look at some Globe phenology data in action for 3 protocols: Budburst, Green Up, and Green Down. And then we'll wrap up by discussing a new phenology and climate project that is going on as part of the SCRC, as well as outline some upcoming important dates for the SCRC. So what is phenology? Phenology is the study of living organisms' response to seasonal and climatic changes in their environment. So for example, you might ask, when do flowers bloom in the spring? Or when do birds migrate to warmer climates for winter? Both of these examples would be studied by the study of phenology because their plants and animals are all living things, and how they respond to their environment and the seasons is all part of the study of phenology. So how does phenology relate to climate? Well, by definition that I just mentioned, phenology studies how organisms respond to seasonal and climatic changes. So things like variations in day length or the duration of sunlight, the amount and timing of precipitation, the temperature, and other life-controlling factors. Those are all climate factors that affect living things. And so that's how important phenology is to climate, because climate really impacts phenology and life cycles. An example would be about the length of the growing season. So the period of time between green up and senescence, senescence being the time that plants age and start to decay and die off, is known as the growing season. And if that time of the growing season, maybe its length, is changing over time, that might be an indication of global climate change. So let's look at an example of this actually. This plot here is showing the Normalized Difference Vegetation Index. It's an index that's measured from remote sensing data from satellites that fly up in outer space looking down at the Earth. And it's looking at the greenness of plants. So on the lower bottom axis, we're looking at time throughout the year, the days of the year. And then the vertical axis is looking at the actual measure of the index. And so the higher the index, the more green that the satellite is seeing. And we're looking at this data for more than 1 year. We're looking at it starting from the early 80s all the way through the mid 90s. And what we're seeing in this data is not only is the greenness factor getting higher during the peak of summertime, but the start of the growing season is roughly about 6 days earlier, and the end of the growing season is roughly 4 days later. Now, so this is indicating that over time, the growing season is getting longer, but this is based on satellite data. And so there's a real need for observations on the ground, and this is where Globe can really help. So Globe has several phenology protocols. The ones that we have are Budburst, Green Up, Green Down, Lilac Phenology, Ruby-throated hummingbird, phenological gardens, seaweed reproduction phenology, and Arctic bird migration monitoring. As you can see, these all either relate to plants or animals and studying how they respond to seasons and climate. Today's webinar, we're going to focus on the first three: budburst, green up, and green down. So let's start with budburst. Budburst is the emergence of new leaves on plants. Budburst signals the beginning of the growing season as well, so it's a really important time of measurements to take. We measure budburst by observing the tree twice a week until the first budburst is seen, and then daily until there are 3 separate places on the tree where budburst has occurred. It's important when you're taking budburst measurements to start at least 2 weeks prior to the anticipated budburst, or maybe even sooner than that, because of the fact that there is an indication that budburst is happening earlier and earlier. If we look at some of the globe data, we'll see just that. This is globe data from a school in Norway. This school has been reporting globe data or phenology data on budburst since 1999. So using this long record of budburst data, I was able to ask the question, how has the timing of budburst changed over time? And at this particular school, you can see that when I put the trend line in the plot, that it's actually happening sooner. So across the bottom of the plot are each year, and then across the vertical axis we have the month and day, all of these occurring in the month of May. And then each individual point is the date of budburst for that year. You do see that there is a lot of variability, the points go up and down a lot, but that trend line is showing that there is a general increase. Back in 1999, budburst was happening around the middle of the month of May for this particular tree in Norway. And by 2011, it's happening almost 5 days sooner on average. Luckily, there are several other schools in the GLOBE database that have a long history of budburst data as well. These are 2 more schools, one in Germany and one in Croatia. And I was able to plot 3 different trees for each of these schools. Both of these schools plotted several different tree species, or recorded data for several different tree species. And we're looking at data from about 2000 all the way up until 2011 or 2012. And you can see, again, for all of these tree species, there's typically an increase in the timing of budburst over time. So it's getting earlier. So the same trend that we saw in Norway. You still see a lot of variation among the points. There's a lot of up and down, but the trend is very clear over the last decade. When I was looking at this data, though, there was something else that jumped out at me. You'll notice that 2008 was in a very anomalously early year for budburst. And so when I was looking at this, especially because it was very obvious in Croatia, all 3 of the tree species had a very early budburst that year. There was also at least 1 tree species in Germany that had a very early budburst that year as well. So it started to make me wonder what climate factors might have had an impact on that. And so I started to look at some of the other data for these schools. These schools also collected temperature data. I looked at their maximum temperature data and their solar noon temperature data and their minimum temperature data. And this is a time series plot of their minimum air temperature data. The green is the school from Germany and the red is the school from Croatia. And this is over about a 10-year period, including 2008. What I noticed is that, say for the school in Germany, the minimum temperature in the middle of winter typically got down to below minus 10 degrees Celsius in the early years of this decade, maybe around minus 10, minus 12. But in 2008, the minimum temperature rarely got below around minus 5 degrees C. The same thing happened for the school in Croatia. The minimum temperature in the winter typically got down to around minus 5 degrees C, but then in the 2008 winter, it rarely got below zero. So again, in both of these locations, the 2008 winter was actually quite warmer than normal. You can see that typically it was much cooler both before and after the 2008 period. And so this could be one factor leading to the really early budburst in 2008. These are just some of the questions that you can answer when you look at the data, and when you also have other atmosphere and maybe soil data to look at to try to understand what's happening in the phenological cycles. So moving on to green up. Green up occurs after budburst, and green up is just the stage in which the leaf grows. We measure green up by measuring the length of the leaf on a tree until it stops growing. We can also do green up for grass, and in that case you would just measure the length of a blade of grass as it grows. You can see here in the pictures below, the tree goes from being quite barren without any leaves in the beginning of spring to having full foliage green leaves at So this is showing data from one school in Alaska from 2005. So this is just one season's worth of budburst and green up data throughout the month of May. You can see the date of May 8th was when budburst occurred, and then from there on out, 4 different leaves were measured as the protocol dictates. And you can see those curves for the rate of growth of those different 4 leaves. So if we wanted to study the green up data from a climate perspective, first of all, we would need more than 1 year of data. And we might ask some questions like, how does the rate of green up change from year to year? Do the leaves grow quicker or slower? Is that trend happening over time? Or what climate factors might be relating to this? So how does that green up cycle relate to other climate variables? And then there's green down. The green down is just the time period when plants' leaves start to turn color, and it goes all the way until they fall off. This marks the end of the growing season then as well. We measure green down in GLOBE by comparing leaf color to the GLOBE plant color guide, which is pictured in the lower right corner of this slide. So again, here's some GLOBE data. This one's from a school in the UK. For 2 different species, the one column is one species of tree and the other column is another. And because the protocol dictates you do 4 leaves, that's why there's 4 rows, leaf 1, 2, 3, and 4. You can see the coloration changes as these leaves go through green down. And first of all, you can see some differences between the species, not only in the time and the rate of green down. It takes a little bit longer for the species on the left to fully green down and to fall off, but also the colors that the tree undergoes as it colors. So some questions that you could ask when you look at green down data would be, how does the green down differ between species? And then to put a climate perspective on it, you would want to look at more than 1 year of data and maybe look at how does the green down rate or the green down timing change from year to year. So what time does green down begin? How does that change from year to year? Is it happening later? Or how quickly is green down happening? That's the rate of change. And then again, you could also relate this to other climate variables like air temperature, precipitation, or soil temperature, soil moisture, or other climate variables that you think might be having an impact on the green down cycle. So we can also look at this from a full annual cycle because all 3 of these protocols that we've been discussing occur every year: budburst, then green up, and then green down. It's the full annual cycle of the deciduous plants. And so this is just one way that we can look at this for a school in Japan where we have budburst time, then the green up trend, and then the green down trend for 4 different leaves. So that's why there's 4 different rows. And then the bottom panel is showing temperature and precipitation data on the same plot. So we're looking at the maximum and minimum temperature throughout the year, as well as the precipitation data in the green bars. And so looking at it from this way, you could look at and link how temperature and precipitation may relate to the phenological cycle. But again, to do this for a climate perspective, you want to do this for more than 1 year and see how things are changing from year to year. Also look to see if there's any trends in how it's been changing. So the Student Climate Research Campaign has several intensive observing periods, or IOPs, and one new IOP this year is the Phenology and Climate Project. The Phenology and Climate Project aims to answer several very important science questions like, what are the best indicators to define the onset and end of the growing season? These indicators may be air temperature, precipitation, soil temperature, or soil moisture. There could be others as well. How well do satellite-based observations of vegetation, such as the NDVI, that vegetation index that we looked at earlier, how does that satellite measurement compare with the ground-based observations of green up or green down that we measure in GLOBE? And how much do the phenology measurements vary from year to year? Are there any trends happening for schools that have a long history of phenology measurements? What kind of trends do we see? And we looked at that for 3 schools earlier, and we were seeing trends that Budburst is happening earlier and earlier. So the Phenology and Climate Project is designed to collect ground-based data with GLOBE protocols to help answer these questions. And we encourage your participation in this project. Like more information about the Phenology and Climate Project, including all the instructions on how to participate, you can go to the Phenology and Climate Project website. The URL is listed at the bottom of the screen. It's quite long, so if you want to also have a quick link to it, you can go into the bottom of the webinar window. There's a web links box, and the top web link is the Globe Phenology and Climate Project. If you click on that, that should take you to the Globe Phenology and Climate Project website in a browser. One other feature that I'd like to draw your attention to on the Globe Phenology and Climate Project website is the discussion forum. It's over in the left column, bottom link, will take you to a discussion forum category on the Phenology and Climate Project. This is a new feature in the new Globe website that we hope everyone will take advantage of, participating in discussion forums, either by asking questions of the community to get help or just see what's happening in other parts of the world compared to your own, as well as reporting what you're doing and sharing your experiences with the community so that we can really work together to answer some of these important science questions. So, before I conclude, I want to highlight some important upcoming dates for the SCRC. As I just mentioned, the Phenology and Climate Project, that IOP goes all the way from September, which was last month, through June of next year. Now, the reason why we have such a long time period is because Budburst, Green Up, and Green Down occur in different times all over the world. And so what we need you to do is determine what time frame Budburst, Green Up, and Green Down occur near you in your school, and then plan to start taking measurements at least twice per week during those times. But like I said before, start early just in case, because some of these things are happening earlier than what we would expect. And then if possible, we're asking participants to take air temperature, precipitation, soil temperature, and soil moisture measurements near those phenology sites so that we can measure those potential indicators of the growing season right there with our phenology measurements to help answer that first question about which of these factors might be the best indicator of the growing season. Please take some time to plan out when these phenological processes happen near you and mark it on your calendar to start taking those measurements at the appropriate time. Right now, in the Globe Program Office, we've been taking green down measurements because the trees here in Colorado have started changing. We started taking these measurements about a month ago, and we just recently started to see that our leaves are starting to turn color from the first one that we observed. Another important date is the Climate and Land Cover IOP. Now that it's October, we have this Climate and Land Cover IOP just beginning. We do have some new technology. The new website has a new photo upload option. So there are new updated instructions on the Climate and Land Cover Project page. But again, if you have any questions, please always email us at science@globe.gov. But we encourage you to get your cameras out and go out and take photographs of land cover near your school in north, south, east, and west directions. In the next SCRC webinar, which will be on using long-term data to study climate with the GHCN dataset, will be on the 23rd of October, so please mark your calendars. This webinar will be discussing the Global Historical Climate Network, or GHCN dataset, which is the data that we are providing from GLOBE for you to use in your climate studies. This data has some records that go back over 100 years of air temperature and precipitation data. So if you're interested in learning more about that data set, please tune in on the 23rd of October. With that, I'd like to thank you for attending, and I will answer some of the questions that are coming in. I see Maria has a question. Oh, let me see. Maria's question says, I always get confused on how to identify the beginning of Budburst, Green Up, and Green Down. We identified the one budburst in one branch, 2 branches. The green down started when one branch started to show yellow. So I apologize that I am not the phenology expert. We were hoping that Elena and Rico could be with us today to help answer some of these questions. So I will answer it the best I can, and then we will definitely get back with you, Maria, to help make sure that we have a Globe Phenology Master Trainer answer this question. But my understanding of the protocol for budburst is that you notice it first in one place, but you do have to notice it 3 other places for the final budburst measurement. For the green down, we have a couple different branches. We have 4 different leaves that you need to measure. So the green down itself doesn't necessarily start based on any one branch. You could actually probably take the average of the time from all 4. That's why it's important to take more than one measurement, because the tree will green down differently in different parts of the tree. So that's why the protocol requires you to take 4 different leaves at the end of 4 different branches. Plant color guide is a problem because it's not easy to find in Peru. Question, Claudia, I do not know the answer to that. And get back to you. I apologize. Oh yeah, Julie is making a good point that these questions, if you post them on the discussion board, then the entire Globe community would be able to see them and contribute to the answer. And I was told that Virgil had a question earlier. Find near phenology site. Was that the question? Yeah. For the Phenology and Climate Project. So some of these measurements, like the soil and the atmosphere measurements, you have to define an atmosphere site. And there are certain requirements for your atmosphere site. And so to have your shelter and your precipitation measurements be right under a tree would not be good. So you cannot have it be exactly at your phenology site for those type of measurements. However, soil temperature or soil moisture you could do right at your phenology site as close to your tree as possible. So the soil measurements you could do right there. You could define a soil site close to your phenology site as long as it still meets the soil requirements. For the atmosphere ones, like air temperature and precipitation, we just ask that if your just have it be as close as possible. Because like I said, we don't want you doing it right under the tree. You still have to follow the rules for an atmosphere site. Can I use soil and air temperature from a local weather bureau? If it's close, like how close is the local weather bureau to your tree? I mean, if you can take your own measurements closer than the local weather bureau, that would be ideal. But again, we just want to make sure that we have fairly close air temperature and precipitation data. I don't have any specific guidelines on distance because we want to be flexible. We know that it's going to be different for every school. We want as many measurements as possible. And so the measurements that are a little bit farther away, we might have to extrapolate and interpolate a little bit, but whatever you can get is going to be helpful. I answered that okay, Virgil? More questions? Thank you, Claudia. Thank you all for attending. All right, so if there are not any more questions coming in, we'll go ahead and conclude the webinar. But as Julie mentioned, please join our discussion forums for all the different SCRC IOPs. We have one for phenology and climate, climate and land cover, and the Great Global Investigation of Climate. Do you have questions coming in from Virgil? We also can always be reached if you have questions you want to email us at science@globe.gov. Like Julie mentioned, the discussion forum would be great because if you have a common question, other people in the community might. How do we make graphs like you did? Well, so some of the graphs that I showed were based off the old visualization system. Some of them were were given to me by Elena and Rico, so I would need to check with them on if they have any special software. But we do have the new visualization system that unfortunately isn't completely ready for plotting all the phenology data, but it's in progress. And so hopefully in the next month or two, we'll have the new visualization system up and running and be able to either recreate the plots that we did with the old viz system or actually have better ones. Right now, from what I've seen, the new visualization system is a lot nicer looking plots. You access those graphs. Virgil, if you want to email science@globe.gov, I can try to connect you with some of those graphs and with Elena and Rico. Also, some of the graphs that I showed today, I just did myself with Microsoft Excel. I pulled the data, the Budburst data, and I just plotted it using the spreadsheet program, Microsoft Excel. All right, are there any other questions that I can answer? Certainly appreciate everybody attending, and we look forward to seeing all of your phenology data and land cover data and other climate data. And we hope that you'll all get out and get your schools entering lots and lots of data for us. In the Student Climate Research Campaign. Great, we'll see you on the web. Yes, let's all make sure to connect on the website. All right, we'll go ahead and conclude the webinar. Thank you again, everyone.